Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip, and today I'm going to be talking to you about array basics. So far, when we've talked about variables, we've only been able to store one value at a time in a variable, maybe one integer, one float, one string. And that works fine, but what if we need to read in or store or process a dictionary that's got 100,000 words in it? Would we want to use 100,000 variables? That would be really inefficient. We'd have to come up with 100,000 unique names for those variables. It would just be a pain. So we need a way to store many values in one variable. And the most basic way to do this is using the data structure, which is the array. So computers are powerful because they can do many operations per second, and it's loops that allow that to happen. But computers are also powerful because they can store huge amounts of data and do operations on those huge amounts of data, and arrays and other data structures you might learn about later allow this to happen. So arrays are objects in Java and in processing, just like strings are objects. So this picture down here shows what an array kind of looks like. It can hold some number of values of one type. So you can have an array that holds a whole bunch of integers. You can have an array that holds a whole bunch of floats. You can have an array that holds a whole bunch of strings. So all the different values that are held in an array have to be of the same type. It's homogeneous. And an array is created to hold a specific number of values. So we might call that number n. And it can be 2 values, or it can be 20, or it can be 3,000. The thing to know about an array is that once you create it and say how many values it's going to store, you can't change that ever. It's always going to be able to store that many values, no more and no less. So the number of values that can be stored is pretty much anything that's non-negative, of course. You do have to be careful that if you create an array that is way too large, you may not have enough memory in your computer for it. So this array down here is an array of 7 int values. It's called myIntArray. That's the name of it. You'll see that over here. And the int array is a reference variable, and the array is actually over here. So this is a group of memory allocated together. It's got 7 slots in it, holding 7 different integer values, 6, 0, -5, etc. And we actually also keep track of specifically how many slots there are in the array. Okay, so the length of this array is 7, and the values in the array are indexed from 0 to 6. So we'll talk a little bit more about this in more detail. So here's the anatomy. An array always knows how many values it can contain, and that is its length. So here we have 7. And even if all of these values were 0, we hadn't really put real numbers in here yet, the length would still be 7. The length refers to the number of slots there are. Okay? That length can never ever change once you've created the array. So if you need an array to get bigger, what you're going to have to do is create a bigger array and copy the values from the smaller array into the bigger. Each element in an array has an index or a subscript. So this element is the number 6, and it has an index of 0. So there are a bunch of elements here, 6, 0, -5, 42, etc. And the subscripts go from 0 to length -1. So our length is 7, the subscripts go from 0 to 6. And that's because, again, computer scientists always count from 0. So this should look familiar to you because strings are done the same way in terms of how we index the characters in a string. So here's the elements, the numbers that are stored in the array, and the indices or subscripts are the numbers that tell us which slot and allow us to refer to and get things out of specific slots in the array. So again, every element here has the same type. Notice these are all ints. None of them are floats, none of them are chars, none of them are strings. It's all the same type. All right, so it's great that we can see what arrays look like, but we need to be able to create them. And there are basically 2 steps to creating an array. Because an array is an object, we have to create a reference variable on the stack that will point to the array, and then we actually have to create the array object. So the reference variable goes on the stack. So in this case, we have a reference variable to an integer array, and it's called myIntArray. And it's null right now because it's not actually pointing to an array yet. So this just creates the reference variable. And then we actually have to create the actual array that's going to hold the memory. So this means we're saying we need the computer to give us some memory on the heap, and we're going to tell it how much. We're going to tell it how many slots we need so that it knows how much memory to allocate on the heap. And then we'll assign it back to the reference variable. So here's our array we created. We asked for an array, and we said we wanted one that had 7 slots to hold 7 integers. And so the computer knows how big integers are and gives us enough memory to hold 7 consecutive integers. And then in the end, we have to say, this array that we've created, make our reference variable point to it. Okay, so let's look at the first part. How do we declare an array reference variable? It's done the way we declare other variable names, where we have a type and then a name. The only thing that's different is we have to add square brackets after the type. So we've got 4 examples here. We have an array of ints. So we've got int square bracket, and we have our name some ints. So this creates a reference variable on our stack. The name is some ints, and this can point to any array of ints. Right now it's not pointing to anything, so its value is null. Right here we have a string array. So string, the type, open square bracket, close square bracket, and then the name we gave it, which is my array of strings. We could call it anything we want, but that's the name we chose. So here we have my array of strings. It's a string type reference variable. So the only thing that can be put in here is a pointer to a place in memory where there is an actual array of strings, right? And here we have float, open square bracket, close square bracket. We were calling this one the float array. Again, here's our reference variable, which has null because we haven't assigned it to anything yet. And here we have an array of colors. So again, color being a primitive type in processing. So we have color, open bracket, close bracket. We're calling it some colors. Here's our reference variable on the stack. And right now it is not yet pointing at anything. So note that when we're declaring the reference variable, we never put a number inside these square brackets because this can point to an array of ints. It can point to an array that has 3 ints in it, but it could also point to an array that has 20 ints in it. So the reference variable doesn't need to know how big the array is that it's pointing at. It just needs to know what type. So this some ints reference variable can point to any array of ints, no matter how big. Okay, and then the type can hold a reference to any array of that type of data. But the array variable, these variables, some ints, float array, my array of strings, and some colors, these do not actually hold the array, okay? The array is created separately on the heap. So this is a little bit different because when we look at this example of int I, we know that int I can actually hold a single int value. When we recall the pictures of the box, we'd have something like, here's our box, and it's an int, and it's called I, and then we actually put the number 5 in it or something like that. So the value is stored right in the variable. With arrays, it's only a reference. So the array isn't stored inside this box. All that's going to be in this box is either null or a memory address that points to where that array is. So really, really important to note that doing this does not actually create an array. It just creates a variable on our stack that can point to an array. All right, so now we actually want to create an array. So let's say we want to create an array of ints and we want to have 7 slots. So we have to use this new keyword, which is a special keyword in Java. And then we use our type again and the square brackets again, but this time we actually have to say how big to make the array. So how many slots we need. So this is the thing that creates the array on the stack. And then the equal sign here says, take the memory of this thing once it's created and put it into our reference variable some ints. Okay, so this looks like this. When we call new int 7, what we get is this. We get space on the heap created, we get a length stored with 7, we get 7 slots, and because this is ints, these get filled with a default value of 0. Right, So creating this also gives us a reference pointer, which is the memory address for where this is located on the heap. And it's important to note that you absolutely have to put a number in here. If you don't put a number in here, it won't compile. And that number, of course, has to be non-negative. You can't say create an array of -3 slots because that just doesn't make any sense. So the length of this array can never change once we've made it, but we can change the values in the slots. So we can put different values in here, we can get these values out, and we'll see more about that later. So when we create arrays, they are filled with a default value that makes sense. So when we're creating an array of ints, it's going to be filled with 0. When we're creating an array of floats, it will be filled with 0.0 in each slot. If we create an array of booleans, the default value in each slot would be false. If we create an array of chars, the default value is /0. And if we create an array of objects, like strings or any other objects that you might have, the default value in these slots is going to be null because they aren't yet pointing to other objects. Okay, so it's really important to remember that 2 steps are needed. When we do this declaration, int x, this creates a reference that can point to an array object, but doesn't create the array object. This expression creates the array object and gives us a reference for it, but this expression by itself doesn't store that reference anywhere. We need an equal sign to assign it to something, and we typically need to assign it to an array reference variable. So typically we want to do these 2 things at the same time. So this is what you will almost always see. Int, open square bracket, close square bracket, no number, our name of our array, and then equals new int with the number in it, okay? So this says create the array and assign it to this reference variable. You can do these 2 steps separately. So int, open square bracket, close square bracket, x on one line, and then later on in your code, you could say x equals new int 7. Until you get to this line, the reference variable x will contain null. So this option of doing it all in one line or doing it separately, you've seen before. We've showed you that you can do this with regular variables like this. We can do int x equals 23, or you can do int x and then later on say x equals 23. Either one works. So let's look at some examples of this. When we want to create arrays, we need to remember to declare the reference variable and instantiate. That's a very specific word for creating arrays or objects. And we'll do them here in some on the same line and some in separate lines. So this is the declarations, and these are the bits of code that actually create the arrays. So in our first example, we're creating an array of doubles. We're calling it game scores. So this is our reference variable that can point to an array of doubles. And over here, we actually create this new array of doubles, and we say we're going to have 5,000 values in it. Okay, so again, this is always going to be an int. We're going to say we want to be able to store 5,000 double values, right? So then we can create an array of strings, and we call it blog comments. This is our reference variable that we're creating over here. And then this actually creates the array on the heap to hold 200 strings. So the 200 slots in this case would all hold null because string is an object. The 5,000 slots up here would hold 0, 0. So let me just write that. This is going to hold 0, 0, 0.0. These ones are all going to hold null inside. Okay, we're going to have 200 null values until we actually assign them to something. This one, new long, is going to have zeros as well. Okay. So, and then in this example, we have an array of int numbers. So this is, we're creating a reference variable that can point to an array of ints. We're calling it numbers, but we're not immediately assigning it to anything. Later on in our code, we can say numbers equals new int 10, and this is creating an array that can hold 10 ints whose default value will be 0, and assign that memory of that location on the heap to our numbers array reference variable. So these things over here are stored on the stack, and the actual array objects that might be of varying size are stored on the heap. So here's a visual of what's stored on the stack, what's stored on the heap. And this is a refresher on the other types of data that we've looked at. So the stack contains all the primitive types. So we've got int a and a value in here, float x and its value, boolean b and its value, okay? And then it contains references to other data. So here we have a string reference variable called 1, a string reference variable called 2, and there are memory addresses in here that point to things on the heap. So over here is our string object that contains testing, and this contains the memory of that in heap. And over here we have our string object student. This contains the memory address of where student is stored on the heap. So arrays are similar to these objects. Here we have an array reference variable called nums, and it is pointing to an array that is stored over here on the heap that happens to be an array of 7 ints. Here we have an array reference variable that points to Boolean arrays. It's called options, and it contains a memory address that is pointing to this array over here, which happens to contain 3 Boolean values. So we've mentioned the null word a few times. Null is a special value, a special key word, and it means no object. It means right now this reference variable is not pointing to anything on the heap. It doesn't have a heap memory address at all, okay? So a reference variable, when you create it, if you don't immediately on the same line assign an object to it, it is going to contain the value null. So in this example, we say we want a reference variable that can point to integer arrays, and we want it to be called the data. When this line executes, that reference variable is going to be created, but it's going to have null inside of it, okay? And later on in our code, we can then look at this reference variable and we can do an equality test. Does what's in the data actually equal null? And so this will, in this case, this will return true. And so that means that it's not pointing at an array yet. So we can go ahead and create one. So then we can say the data equals new int and create an array of size, whatever size happens to be. Okay. So then we create our array over here. And now this no longer contains null, and it's actually pointing at our array, right? And then later on in the code, we can check to make sure that our array reference variable, the data, isn't null. And this is a way of saying, are you actually pointing at a real array? And if it isn't null, then it is pointing at an array, and then we can actually access that array and do something with it. Okay, so again, about the null reference, remember that any types that start with a capital letter are objects. And so those variables are actually reference variables. So both object reference variables and array reference variables can be set to null. So we know that they're null when they're created if we don't assign something to them, but we can also actually explicitly set them to null as the programmer. And that's a way to say, forget about this thing that you're pointing at. So let's look at an example. Imagine we have this line of code, string s equals hi there. So s holds the address of the string object. It looks like this. So we have our reference variable, it's of type string, it's called s, and it's pointing at the string object that contains hi there. Sorry. Now, if we then execute this line, s equals null, we're assigning null to our reference variable and saying, forget that address that you had. And what that does is it causes the link to be broken. So now we don't have anything pointing at the string object, and our string s is now set to null. So in Java and in processing, if there's nothing pointing at an object after a while, the memory that object was taking up will actually just be freed and made available to use in other ways. That's called garbage collection. So it's important to note, especially with strings, students often get confused, that a string reference variable that is set to null is not the same thing as a string that is an empty string. Okay, so you could have a string that is pointing to a string object that is the empty string, and there would still be an arrow there and it wouldn't be null. Okay, so One more word about default values. So whenever processing is compiling a program, it wants to check to make sure variables have been initialized. And you've seen this because you've probably been warned when you're trying to use a variable that you haven't actually given a value to. It's harder to do that with arrays, to know whether or not there's things in every slot. And so by default, processing will just fill arrays with some kind of default value when the array is created. So for numerical types, we're going to fill it with 0 or 0.0. For Booleans, we're going to fill it with false. For any string or other objects, we're just going to fill it with null. All right. It is important for you to understand that this is something that processing in Java does, filling arrays with default values. Not all languages will do this, and so trying to get values out of an array that hasn't been initialized can cause a lot of bugs in other programming languages. Okay, so that's it for your introduction to arrays. Thanks for watching.